When examining a Thomas and Betts circuit breaker, the markings indicate that it is classified by Underwriters Laboratories, known as UL, for use in UL-listed panel boards manufactured by Challenger, General Electric, Murray, Siemens, Thomas and Betts, and Westinghouse. This classification allows the breaker to be used in place of UL-listed circuit breakers. The UL product markings specifies that the circuit breaker is listed for use in circuit breaker enclosures and panel boards intended and marked for its use. It is classified for use where the available short circuit current is 10,000 amps at 120 volts or 240 volts alternating current or less, within the compatible panel boards detailed in publication number T5651B63, which is provided with the circuit breaker. If the UL listing markings in the breaker are adhered to, it would violate the listing to use the breaker in an enclosure that is not included in publication number T5651B63. A copy of that publication may be obtained from Thomas and Betts. It is also advisable to check for any supplements to the UL listing for the breaker, as these might include additional compatible panel boards approved since the original UL listing was issued. These supplements can be obtained from UL. In some instances, panel board manufacturers may issue a field listing for the use of specific breakers not listed in the original UL listing. These field listings are typically a response to a field problem or to allow the use of a breaker unavailable when the panel board was initially released. The panel board field listing should be available from the panel board manufacturer. If the breaker is used in a non-compatible panel board, the installed equipment is considered not listed for the application, resulting in a violation of the National Electrical Code, known as NEC. The UL listing and classification markings on circuit breakers and panel boards are essential for ensuring electrical safety and code compliance. These markings provide critical information about the breaker's intended use, its compatibility with specific panel boards, and its short circuit current rating. A UL listing indicates that UL has tested the product and found it to meet its safety requirements. A UL classification means the product has been evaluated for specific properties, a limited range of hazards, or suitability for use under limited conditions. The NEC requires that electrical equipment be installed and used in accordance with its listing and labeling. This requirement ensures that the equipment is used as intended by the manufacturer and that it meets minimum safety standards. Using a circuit breaker in a panel board for which it is not listed or classified can create a potentially hazardous situation. The breaker may not be able to properly interrupt a short circuit or overload, which could lead to equipment damage, fire, or electrical shock. Compatibility issues can arise from differences of physical dimensions, busbar configurations, or interrupting capacity requirements. The manufacturer's instructions and relevant UL publications provide detailed information on compatible panel boards. Consulting these resources helps ensure the correct application of circuit breakers. Field listings are special approvals granted by panel board manufacturers for using specific breakers not covered in the original UL listing. These listings address unique circumstances or to accommodate breakers that were not available when the panel board was first released. Field listings provide an alternative pathway for approving breaker applications outside the scope of the standard UL listing, ensuring safety and compliance in specific scenarios. Understanding the importance of UL listing, classification, and field listings is crucial for electrical inspectors, contractors, and engineers. When installing or inspecting electrical equipment, always verify that the circuit breakers are properly listed and classified for use in the panel boards where they are installed. Consult the manufacturer's instructions and relevant UL publications to ensure compatibility. If there are any doubts about the proper application of a circuit breaker, contact the manufacturer or a qualified electrical engineer for guidance. Proper adherence to these guidelines ensures electrical safety and compliance with the NEC. Several factors contribute to the compatibility between a circuit breaker and a panel board. Firstly, the physical dimensions of the circuit breaker must match the available space within the panel board. The breaker needs to fit securely onto the bus bars and within the panel board enclosure without any physical obstructions. Secondly, the busbar configuration of the panel board must align with the breaker's connection points. The breaker's terminals need to make proper electrical contact with the busbars to ensure reliable power distribution. Thirdly, the interrupting capacity of the circuit breaker must be equal to or greater than the available short circuit current at the panelboard's location. The interrupting capacity is the maximum fault current that the breaker can safely interrupt without failing. The available short circuit current is the amount of current that could flow in a short circuit condition at the panelboard. Fourthly, the voltage rating of the circuit breaker must match the voltage rating of the panelboard. Using a breaker with a low voltage rating than the panelboard can lead to premature failure or hazardous conditions. Fifthly, the UL listing or classification of the circuit breaker must include the specific panelboard in which it is being installed. The UL listing verifies that the breaker has been tested and approved for use in that particular panelboard model. When selecting a circuit breaker for a panelboard, consider firstly the physical compatibility. Ensure the breaker fits properly into the panelboard and connects securely to the bus bars. Secondly, the interrupting capacity must be adequate. Determine the available short circuit current at the panelboard location and select a breaker with an equal or higher interrupting capacity. Thirdly, verify the voltage rating. Make sure the breaker's voltage rating matches the panelboard's voltage rating. Fourthly, confirm the UL listing. Check that the breaker is listed or classified for use in the specific panelboard model. Fifthly, consult manufacturer's documentation. Refer to the panelboard and circuit breaker manufacturer's documentation for compatibility information and installation instructions. Field modifications to electrical equipment can affect its safety and performance. Modifying a panelboard to accommodate a circuit breaker that is not listed or classified for use in that panelboard can create potential hazards. These hazards include reduced interrupting capacity, improper fit, and compromised electrical connections. The NEC generally prohibits modifications to listed equipment unless the equipment is evaluated and approved by a qualified testing laboratory, and this requirement helps maintain the integrity and safety of electrical installations. Only qualified personnel should perform electrical work. Working with electrical equipment requires specialized knowledge and skills. Improper installation or maintenance can lead to electric shock, fire, and other hazards. Only licensed electricians and qualified personnel should perform electrical work, and they should always follow safe work practices and wear appropriate personal protective equipment. Regular inspections and maintenance can help prevent electrical problems. Electrical systems should be inspected regularly to identify potential hazards and ensure that equipment is in good working order. Maintenance tasks such as tightening connections, cleaning components, and testing circuit breakers can help prevent failures and extend the lifespan of electrical equipment. Effective communication between electrical inspectors, contractors, and engineers is essential for ensuring code compliance and safety. Clear and concise communication can help prevent misunderstandings, resolve issues quickly, and ensure that electrical installations meet all applicable requirements. Regular training and continuing education are important for keeping electrical professionals up to date on the latest codes, standards, and technologies. The electrical industry is constantly evolving, and staying informed helps ensure that electrical work is performed safely and effectively. When evaluating a circuit breaker for use in a panelboard, firstly verify the circuit breaker's UL listing or classification. The listing should clearly state the specific panelboards with which the breaker is compatible. Secondly, check the panelboard's labeling. The panelboard should have a label indicating the types of circuit breakers that are approved for use in the panelboard. Thirdly, consult the manufacturer's documentation. The manufacturer's documentation for both the circuit breaker and the panelboard will provide detailed information about compatibility and installation requirements. Fourthly, inspect the physical fit. Ensure that the circuit breaker fits properly into the panelboard and connects securely to the bus bars. Fifthly, confirm the interrupting capacity. Verify that the circuit breaker's interrupting capacity is equal to or greater than the available short circuit current at the panelboard's location. Sixthly, check the voltage rating. Make sure that the circuit breaker's voltage rating matches the voltage rating of the panelboard. Seventhly, look for any field listings. Check to see if the panelboard manufacturer has issued a field listing approving the use of the specific circuit breaker in the panelboard. Eighthly, if there are any doubts, contact the manufacturer. If you are unsure about the compatibility of a circuit breaker and a panelboard, contact the manufacturer of either the circuit breaker or the panelboard for assistance. Ignoring these verification steps can lead to electrical hazards, code violations, and potential equipment damage. Compliance with the National Electrical Code and adherence to manufacturer specifications are essential for ensuring electrical safety and reliability. Short-circuit current ratings are a crucial aspect of electrical safety. The available short-circuit current refers to the maximum amount of current that can flow in an electrical circuit during a short-circuit condition. Circuit breakers and other overcurrent protection devices must have an interrupting capacity equal to or greater than the available short-circuit current at their point of installation. The interrupting capacity is the maximum fault current that the device can safely interrupt without failing. If a circuit breaker is installed in a location where the available short-circuit current exceeds its interrupting capacity, the breaker may not be able to properly interrupt the fault current. This can lead to the breaker failing, resulting in equipment damage, fire, or electrical shock. To determine the available short-circuit current at a particular location in an electrical system, it is necessary to perform a short-circuit study. A short-circuit study involves calculating the fault current at various points in the system, taking into account factors such as the utility source impedance, transformer impedances, conductor lengths, and motor contributions. The results of the short-circuit study are used to select circuit breakers and other overcurrent protection devices with adequate interrupting capacity. The NEC requires that electrical equipment be selected and installed so that its interrupting rating is sufficient for the available short-circuit current. This requirement is intended to protect people and property from the hazards of electrical faults. When selecting circuit breakers, it is important to consider the following factors. Firstly, the available short-circuit current at the point of installation. This can be determined through a short-circuit study. Secondly, the circuit breaker's interrupting capacity. This is the maximum fault current that the breaker can safely interrupt. Thirdly, the voltage rating of the circuit breaker. This should match the voltage of the electrical system. Fourthly, the ampere rating of the circuit breaker. This should be selected based on the load that the breaker is intended to protect. Fifthly, the UL listing of the circuit breaker. This indicates that the breaker has been tested and certified to meet safety standards. Regular testing and maintenance of circuit breakers are essential for ensuring that they will function properly in the event of a short circuit. Circuit breakers should be visually inspected for any signs of damage or wear. They should also be tested periodically to verify that they are tripping at their rated current and that their interrupting capacity is still adequate. Proper coordination of circuit breakers is important for minimizing the extent of an electrical outage in the event of a fault. Coordination involves selecting circuit breakers with different tripping characteristics so that the breaker closest to the fault will trip first, isolating the fault and minimizing the impact on the rest of the electrical system. Coordination studies are typically performed by qualified electrical engineers. These studies involve analyzing the tripping characteristics of all circuit breakers in the system and selecting breakers that will coordinate properly. Proper application of field-installed accessory circuit breakers is also very critical to the function of a panel board. Circuit breakers can be supplied with factory-installed accessories, or sometimes they can be field-installed.